Thank you, everybody, for joining. My name is Chad Walker. I'm the product manager for the FlawSense product line, which is the topic of discussion today. And I've been with LaserLinc for 8 years. I'm going to be talking about FlawSense technology and the turnkey solutions that we provide. So with that, we will jump right into it. And if anyone has questions during the presentation, please submit those questions in the Q&A section. And at the end of the presentation, I will go through those. So the agenda for today, we're going to talk a little bit about LaserLinc and the products the solutions we provide. I'm going to go into detail about the FlawSense product line, and then I'm going to talk about the turnkey solutions that we offer with FlawSense. So LaserLinc has been providing inline and offline measurement and inspection equipment for 27 years. We are located in Fairborn, Ohio, and we have turnkey solutions that are focused in hose, pipe, tube, cable, and wire production, generally for medical, industrial, automotive, and aerospace industries. So LaserLinc provides a few key pieces of hardware for measurement and inspection, namely laser micrometers for diameter, ovality, and defect detection, laser line triangulation, which is FlawSense, which provides diameter, ovality, and defect detection, as well as ultrasonic measurement equipment for wall thickness, concentricity, and inner diameter. We also provide software, the Total View software. As the name implies, it is a total view of your production process, so you can visualize how your current process is running in terms of the dimensions, and you can monitor those dimensions against specifications to flag when it goes out of spec. We have SPC, so you can look at statistics about your run, data logging to log important measurements or actions that are taken inside Total View. We also provide closed loop control, so feedback to your extruder to control the diameters of your product. Then we also have Industry 4.0 communication via OPC, so we can communicate to other devices, whether that needs to be software or hardware to react to something in your process. So let's talk about FlawSense. FlawSense is using laser line triangulation. Essentially, it projects a laser onto the part, and our system has at least three gauges to get 360 degrees of coverage. The sensors triangulate the position of that laser, and when coupled with an encoder in your production process, that builds a 3D surface map of your entire product. And from that surface map, we can measure diameter and ovality, and we can perform real-time defect detection. So laser line triangulation is the only technology currently on the market that provides real-time 3D inspection to this level of coverage. So why is laser line triangulation superior? And I'm comparing this to vision systems and laser micrometers, which are the typical inspection and measurement systems found in continuous production. Laser line triangulation provides three-dimensional defect detection, and that is not true of vision systems or laser micrometers. It's more intuitive to set up since it is a dimensional system. You're setting dimensional thresholds for defect detection. Compare that to vision systems that require either that the product is a solid color and has very limited capabilities when it comes to a changing environment, lighting conditions, or if you have text or labels or convolution in your product, you might have to deal with vision AI, which is much more complicated. But since FlawSense is 3D, we don't have to worry about different colors or text on the surface. There's no shape error, and I'm going to talk about this in more detail in a second, but vision systems and laser micrometers suffer from something called shape error. Essentially, if your product is non-round, vision systems and laser micrometers will measure with error in that measurement. Whereas laser line triangulation, since it is creating a 360 contour map, It does not have that issue of shape error. It will accurately measure regardless of the shape. It's also reliable, easy to set up. Um, Again, dimensional thresholds are much easier to set up than AI vision systems or um, diameter changes over time, which is usually how you set up a laser micrometer for defect detection. It's more robust to changing ambient conditions than a vision system. Vision systems are susceptible to lighting changes. Laser line triangulation uses a high-powered laser, and the exposure times on the sensor are significantly lower than a vision system, which essentially means it's immune to ambient lighting, unless that lighting is on the same um, order of power as a class 2 or 3 laser. And it reliably detects 20 to 100 times smaller than a 3-axis laser micrometer, and that's due to the dead zones in laser micrometers. So just a little more detail. We've studied our FlawSense system in terms of accuracy, and we found that we can detect defects as small as 2/10,000ths of an inch. And it reliably, again, detects up to 20 to 100 times smaller than a 3-axis micrometer. And that is due to the dead zones in a laser micrometer. It supports line speeds up to 2,000 feet per minute, but it depends on the defects that you're trying to detect, coupled with the frame rate that we can achieve in FlawSense. Frame rates are generally, up to 10,000 hertz. So that coupled with your line speed will dictate the minimum detectable flaw length. And then it detects regardless of color and text on the surface. Again, vision systems would struggle when there's color or text changes. They would have to be trained to avoid detection of those different colors as they come through. But FlawSense is digitizing the surface into a 3D model and looking for variation in that surface. So it doesn't matter if there's text or color changes. And then finally, you get metadata for every detected defect. So you know the height, depth of the detected defect, you know the exact location, and that location can be sent to other devices so that it's marked for removal or automatically removed. And we'll talk about that more in a second. Shape error, I mentioned this earlier, but if your product is not a perfect circle, that creates error in vision system measurements and laser micrometers. And it has to do with the fact that vision systems and laser micrometers measure point to point per gauge. They do not measure a 360 contour. So with a 3-camera vision system or a 3-axis micrometer, you're going to have 6 measured points around the circumference, compared to FlawSense, which will measure hundreds to thousands of points around the circumference of your product. And the effect is there's uncertainty in your measurement for a vision system and a laser micrometer, up to 7.7% of the diameter in a 3-gauge system. And this is just basic math of calculating dead zones in a micrometer or a vision system in terms of their measurement. And I've done multiple studies with customers, and I can take a CAD file if you have a product that is known to be non-circular and show you the effects of shape error in a 3-axis or any axis gauge, vision system, or micrometer. Yeah, and I've found multiple examples of contours that cannot meet the specifications that a customer requires due to the fact that it's not a perfect circle or it's the actual shape that's being measured. FlawSense, on the other hand, is immune to shape error because it measures hundreds to thousands of points around the circumference, and it measures the depth to those points. So we've tested gauge error, and we found that it's better than 2/10,000ths of an inch. And you compare that to the uncertainty of a vision system or laser micrometer measurement, that's 75 times less error, reliably, 75 times less. And again, we can do a study with you if you're interested in that. So when should you consider FlawSense? It's not right for every situation. Your product must be opaque. If it is clear or translucent, that does pose a problem for FlawSense. We have been successful with clear jackets over an opaque surface. So we can do that, but it depends on the thickness of that clear jacket. And it also cannot be a mirror finish. So there's some applications like metal making metal parts, laser cutting metal that basically leaves it a mirror finish, or if it has a lot of cuts in it that cause reflections of the laser, that can cause issues with measurement. And right now we support diameters from 40 thousandths of an inch up to 2.5 inches. And again, line speeds up to 2,000 feet per minute, but it really depends on your application. So if you currently have a process that is missing defects or you're getting false positives because uh, your your vision system's just flaky on detection, you should consider FlawSense and the fact that it has three-dimensional defect detection. If you're concerned about measurements, if you think that the contour of your products that you're trying to measure are deviate from a circle too much, that can cause measurement error. If you're concerned about that, consider FlawSense as an alternative. And if you are using operators to manually feel for defects, or you have them, if you're not sure, if you're not trusting of your current inspection equipment and the operators have to verify it every time, we can fully automate the process of defect detection and get you to a point where you trust FlawSense and you don't need to rely on operators to verify defects. So we offer turnkey solutions for the following production processes. Continuous production, where you cannot stop the line. We can send a signal to mark the defect as it's going through. Inline sorting, where parts will be cut to length. FlawSense inspects those parts and sends a signal to a blow-off to blow the product into a good pile if it's determined to be good, or it lets it go in the trash if it's determined to have a flaw or is out of spec. Respool operations. So if you have a spool of product and you couldn't inspect it during production, you can spool it through the FlawSense unit, and we can actually interact with your respool line to stop the line such that the defect is right in front of an operator or a cutting machine. And we've had that process be nearly fully automated to where the operator only needs to splice the cut cable together and continue running. And finally, offline inspection. If you have a batch of parts that are cut to length, we can inspect those and give it a go, no go based on defects and whether they're in spec. So here are the three solutions, turnkey solutions that we offer. The first one is the mobile all-in-one system. So FlawSense is on a mobile base with an HMI and all of the electronics needed to run it. You provide power and an encoder signal, and maybe you need to hook up some digital I/O, and then you're good to run. It's suitable for continuous sorting and respool application. It's mobile. It fits through a door. It can come with a NEMA 12K enclosure if you have a dirty environment. It has built-in HMI monitor keyboard and the communication that we discussed earlier. It has roller guides that can be built in. Yeah. The modular station is another turnkey solution that we have. It is used for continuous sorting and respool operations. FlawSense in this case is on a stand and it's bolted to the floor. It's for heavy duty applications. So with the mobile system, it's not bolted to the floor necessarily. And if you have a heavy duty process, you're more likely to drag the unit down the line. So this is for those applications where there's risk for a heavy cable pulling on the system. So the FlawSense unit is bolted to the floor. The electronics enclosure is near the FlawSense unit, and the HMI is somewhere else on the line. It has all the other benefits of a mobile solution. So NEMA 12K is available, and OPC communication and digital I/O. And then finally, we have a Metron. This is our offline batch inspection system. So this is if you have a batch of parts and maybe those parts have different diameters or different tapers, we can set up recipes. It's easy to set up a recipe with different diameters and tapers, apply specifications to those regions, and set up defect detection parameters for different zones on your part. So if you have a part that is more critical, for example, on the tip of a catheter, you can set more stringent defect detection in that zone. And basically, an operator will load the recipe, they'll put the part in the Metron system. That might be by stringing the part on a mandrel and inserting it into the chucks. And the operator hits a button, the FlawSense unit scans over the part, and it gives a go, no-go signal. After you've completed a batch, you get batch statistics. You know exactly which parts did not pass and why. So you even have 3D visuals for all of these defects that are detected that will be visible, and you can compare the real defect on your product to the 3D visual that FlawSense provides. And again, or just like the mobile system, this Metron it's mobile. It has casters. It's basically you plug in power and you're good to go. So next steps, if you are interested, we can perform sample evaluation. If you contact us at info@laserlinc.com and you give us details about your application and provide some samples, we can actually show you exactly the coverage you will see in your production process by putting your product in our Metron and scanning at intervals that will give you the identical coverage you'd see in your production process. And then we'll tell you how viable defect detection is. We'll tell you exactly how large of defects we can detect at your line speed, and tell you if there's any concerns about your specific application. So if you're interested, please reach out to us and we will get your samples evaluated. So if anyone has any questions, please write them in the Q&A section and I will answer them now. I'll wait about a minute. And while we wait, I'll just say, if anyone has pricing questions as well, please reach out to us. We will look at your application and give you a realistic estimate. So I have a question. How does ambient surrounding light affect the FlawSense? So FlawSense uses high-class lasers, and these high-class lasers, they're much brighter than your ambient lighting. So the exposure time in our sensors is very low, and that allows us to ignore the lighting in the ambient environment. So essentially, you can shine a flashlight into the FlawSense sensors, and you won't see any effect. It does not affect defect detection unless you're shining a high-powered laser into the sensor or on the product. It's not going to be an issue. Yeah, so I have a question. Thanks for the demo. Please tell us about dealing with vibrations and product hop. So it is important to keep the product within the field of view. We have two different product lines. One measures up to 29 millimeter diameter, the other up to 69 millimeter diameter. And as long as it's within that region, we can measure diameter and ovality and perform defect detection. Vibration is not a concern as long as the vibration is not so rapid that it's within the exposure time of the gauge, which is in the microseconds. So we have not seen any issues with vibration as long as the product stays within that field of view. I have a question. I have a metal wire in tubing that is opaque. If the metal wire is reflective, could FlawSense work if lighting is adjusted? Oh, metal wires in tubing that is opaque. So it depends. If you're talking about braiding on the outside, that I would need to see samples and evaluate that. If there is an opaque jacket that's covering those wires and it's a reflective surface, that is probably fine. Again, we can do sample evaluation and we'll show you exactly what it'll look like. but there wouldn't be any ambient lighting adjustment needed. It is all the lighting is provided in the gauge with a laser, a high-powered laser. Any other questions? Well, I thank you all for joining. And again, if you reach out to us, we can perform sample evaluation. Love to talk about your applications. And yeah, I think that's all for today. Thank you. Oh, I do see a raised hand. If you would like to talk.
All right, can you hear me?
Yep, I can hear you.
All right, so my question was if we have it's going back to that metal wire and tubing.
Yep.
The tubing itself is some are opaque, but some are translucent to an extent. So I was wondering if FlawSense would work for it, but if we'd have to make an adjustment with lighting to avoid any reflection or intermittent like flashing or anything like that.
Yeah, so if the it's a translucent material with braids inside, that
Mhm.
that could cause issues. I would say I need to see a sample to be certain, but it's not a slam dunk application necessarily.
Got you. Okay. Thank you.
Yep. All right. I think that's it. So thank you, everybody.